Hello, hello. Good evening, good morning. Hello, everyone. Welcome on the next TWF meetup. And today we have a special guest. Our guest is Oscar Dudic. Hello, hello.
Hey,
Nice to have you here. So, let's start with our guest. I will share your screen right now, Oscar, and you can continue with your special thing. So, the event sourcing, sorry, event storming.
no worries, no worries. We will see a bit of that also, but shortly.
Okay, as always, if you want to ask a question, just write it down on the chat in the YouTube. We will, at the end of this meeting, we will cover all of Oscar. Actually, will cover probably most of the questions. If not, as always, you have the recording, so you can watch it later.
Hmm?
Okay, so Oscar, stage is yours. Good luck.
Thank you. My name is Oscar, and for me it's afternoon. So good afternoon and good evening for those that are starting their day, and we will try to have some fun with event sourcing. So as always, I like to start with some story to just get better context of where we could be using event sourcing. And our story will be about the support team, or actually about the user incidents. So as you can see, this is our famous support team. And of course, we have user. And typically, the help desk ticket that is coming is, of course, just instantly rejected with the question about, did you try to turn it off and on again? Fine. But jokes aside, there is more than that. So if we thought about how the journey of our user that is using our help desk looks like, then of course the first thing should happen is that user should be registered, or customer should be registered, because then it has access to our help desk, etc. So it means that they are using our services. And the next thing that user do instantly is that, of course, it logs some incident. And incident is an official terminology in this space. So you can think about it as a bug, or, for example, my computer is not working, or my service isn't available, or I cannot log in, or maybe some calculation is wrong. Whatever it is, user can log this incident either via our system, via email, via mobile. So whatever is the preferred source. And right after we do it, then we need to assign agent. So of course we can select Morris or Roy, like in the Mortal Kombat. Um, so no matter whatever we choose, the agent, when it is assigned, then the agent needs to understand and do some further action and investigate our incident further on. Then usually the first thing to do is the incident prioritization. So it means that we are saying how important is this issue, and how urgent is this issue. And this is really important step, because this is related to our SLA and SLO, because from now on the time will start ticking, tick tick tick. So we have, if it's P1 incident, then we usually don't have a lot of time to respond. And we also should, or actually agent should categorize that incident, because it might be related to many things. And if this help desk agent categorizes that, then quite often it's being pushed to some other people to take that further and understand that better. And eventually agent responds, and agent is placing some action, like usually works for me. And then usually user, when, or customer, when they see such response, then of course at first they are uh, quite angry, but they respond and they say like, okay, that's fine that it works for you, but it doesn't works for me. And such discussion can be taken for some time, so there is some back and forth. And jokes aside, usually it's just about being able to reproduce and properly handle and properly solve the specific incident. So after that, after the agent and customer agree on the reason of this incident, then incident should be resolved. And that means that there was some action taken, maybe some backfix was deployed and new version of our service is available. And then user can start um, to check and verify whether this resolution actually happened, because uh, the we all know that quite often we are getting information that yeah, it should work now, but we are checking and actually it's not working fine. But after customer resolved and acknowledge the resolution, then finally we can close the incident. And why am I telling that to you? Because what you see on the screen is actually, besides the story and the possible things that can happen in our system, in our process of the handling help desk incident, is also we can think about those orange boxes or orange sticky notes. So this is the event storming part that Veronica mentioned. We can think and model and describe our process in terms of those events. So all of those boxes represent a fact. Each event is a different fact about something that has happened. And here we are getting not only some facts, but also possibilities to storytelling. So, event is a fact, is something that happened in the past. It represents the result of the specific business operation. And by definition, events are immutable because what has happened has happened. We cannot change the past unless we are characters from 1984. And if we have a look again and move further, then we can also think about event stream. An event stream, speaking like in a broader terms, it might represent a history of the specific or story of the specific thing. And this thing can be entity. In our case, is the incident, the specific incident. So we see that this specific incident was logged, then agent was assigned, agent responded, and after that, it prioritized and resolved the incident, and then customer acknowledge resolution and close the incident. But we can have, of course, in our system more incident. And if we are trying to model our systems by event and handle the uh, um, upcoming results of our business operations as events, then we are getting event stream for each of our record. So event stream, in other words, is like a sequence of events, ordered sequence of event. And event streams is built from the record ID. So you can think about it like a primary key in a traditional way, plus the list or sequence of events that happened for this particular record. And all of those incidents, all of those events are really important because they represent business facts. As you see, there are no events named like incident created, incident updated, incident deleted, because in real world, there are no such operations. We see that this is, instead of incident created, we have incident logged. We have a various different events representing granular information about precisely what has happened. So agent assigned, incident prioritized, resolved, and so on and so forth. So by that, we can have a better collaboration between the engineering team and also the business team. This is extremely crucial because it brings us the better common understanding. And when we are talking with our business people, like product owners, then it's much easier to have a common way of talking with them because we are talking with them with the business terms that are actually also technical terms eventually. And funny story is that my product owner, hey Camille, you are probably not watching that, but in my project where I started to work with events, then Camille, that was our product owner, and he was a business specialist, but definitely far from being developer. Then he even quickly understood what are events and how important they are. And after some time, he started to saying like, okay, then store or publish this and that event, and they will listen to that and take some further action. And I said like, okay, Camille, you probably spent too much time with us, but that also means that this is really how business is thinking. This is you can say to your business that events are like a critical or checkpoints of our business process. And again, if you have any questions, feel free to ask them. I will try to answer as they go, or as Veronica said, in the end. But I'm looking on the chat. So, Karim, I see that you are excited. I'm also excited. So, thank you. And again, for business, that means that if they are talking with us, then we could easier understand what they mean and also have the straightforward mapping from the business perspective to technical. But for us, it means also a better diagnostic, because if we look on those events, then we clearly see what has happened. And if we are having some issues, or for example, we got bug, or even like a help desk ticket to our system, so like an inception, fixing an issue, incident of our help desk system incident, but nevertheless, let's not go further that way. But for us, you can even take those events, debug the code, and clearly see what went wrong. So that what I show you was the really the overall basics of why you could consider building and modeling your system with events. And thus the name event sourcing, because in this pattern, events are our center, are our source of truth. Everything starts with events, and then we are moving things forward. But we are on the engineering meeting, so let's start to move closer from the big picture and the general thoughts to our code and how we are handling that. So event sourcing could be flattened to some sort of the storage pattern, because first thing that we need to get is the clear intention from the user of what they would like to do. So, for example, they would like to resolve some incident. And this is the request that could be coming from our UI, from our front end, through our API, and then we want to handle that. And at this point, there is no difference between event sourcing and any other pattern, because what we need to do is we need to get this intention and then run the business logic. Okay, there is a single difference. To be able to capture those granular events that you see on the left, we need to also have the clear business intention in command. So if our request or command is like incident updated, then definitely we won't be able to log events like agent assigned, incident resolved. So we need to also name it in the business terms. But this is for good, because we are creating applications to solve business cases. So once we receive the command, then we need to get the state. And in event sourcing, the state are events. There is no other state. So we need to take the stream of events with the specific ID and get all events from that stream. And after that, we need to build our representation of those events. So like, let's say our model with this state at the certain point in time. So we start with the default object, and then we are taking event in the order of appearance and applying it one by one. You can think about it like a for each. You will see that later in code. So when we are getting incident logs, then we can feel that status is pending. Agent ID is null because we don't have yet anyone assign it, and is responded means that is false because we didn't do anything. And when we have agent assigned, then we can update only the relevant information. So in this case, we can set the agent ID. And once we got agent responded, then we can mark that there is some response from our agent. And if our business logic, then we are running our business logic on this state, on this representation of our events, and there is really no difference. We run validation, we run some calculation, we are making decision whether this request is valid. And once we do it, then we are storing another event, and this in this particular case is incident resolved. So simple as that. An important thing is that event is landing as the final event in the stream. So it's append only because we need to know precisely in which order those operations happened. So I promise that we will be moving slowly or maybe a bit faster to the technical definition. So how to store those events? So I can start by saying that definitely not in Kafka, even though a lot of resources are claiming that you should use Kafka for event sourcing, just don't. Um, so where to store it? And luckily, you have me. Because I'm a co-maintainer of Martin, which will be our technical example of how to use event sourcing and the event store in the further part of our webinar. But I also worked in EventStore DB. EventStore DB is the first event store that was natively built for event sourcing. And Martin is an event store that is built on top of the regular relational database. So in our case, Postgres. But there are many more event stores, but those are two that I was involved in creating. And I'm also blogging and having my newsletter. You can check it. But we are not here to talk about my history, but about the history of our incidents, so our event sourcing. So let's get back to the slide with our event streams. We may notice that here all of those streams have key. So as I mentioned, it's like a record ID. You can think about it as a primary key. And we also have value. And this is important because logically, you can think about event stores as key value databases, where key is the record ID and value is a sequence of events. So like a list of events. And that's really important. And in my opinion, it helps to understand what guarantees we can get from the event store. And also about the potential performance issue, and so on and so forth. Because if our database, if event store is a database and it's like a key value store, then we can get the same guarantees that we would expect from the regular databases. So like atomic writes, reading your own writes, optimistic concurrency, and so on and so forth. So can we have a performance issue? Of course we can, because in each database type, we can get a performance issue. And when those performance issues are happening, when we are not understanding what is the typical way of how we should model data in this database. So in relational databases, we are trying to denormalize data, to normalize data. In document databases, we are trying to denormalize it. And in event stores, we are trying to keep our events short, event streams short, because the more events and the bigger they are, then we will need to load more data. But we should not be scared in general by the number of events, because as I mentioned, those events are granular and they should be really focused on the specific business operation. So they should not contain a lot of data. And if so, even if we have like 20 events and all of them have like maybe two properties, then that shouldn't be a big deal, especially that those event stores are optimized for such usage. So, see, this is the example of how it can look like, because quite often event stores are built like a append only log. So we have our physically we have append only log. So this is our, it may represent our file structure like in EventStore DB, or in Marten we have a single table that contains all events, but still logically each event stream is just a, is just a key value pair. So I mentioned Event Store DB is an event store that is natively built for event sourcing, because we have in event sourcing just two operations, basically append at the end of the stream and read all events from stream. And this is, those two operations are sufficient to handle a simple event store. Of course, event stores are usually have more, but those are the most important. And by this simplicity, it's also possible to optimize our storage to be performant and natively built for that. So in Marten, on the other hand, as I mentioned, we have a single relational table. So this is a simplified version of it. And if we have a look, then we have two types of data in this table. So we have metadata, and that represents information like event ID, stream ID, version, type. And we also have data where in Marten it's a blob, it's a JSON. We are serializing the event payload and store it there. So the first question that may arise is that, okay, but is it fine? Is it really fine to keep all events within the single table? And the answer is always, it depends. But let's say that, because even today I got question like, what will happen if I store a lot of data? And now the question is, what does it mean a lot of data? Is 10 millions of records a lot of data, or 50 millions of billion? For relational database, 50 millions of records is not a big deal usually. So especially if we put an index on stream ID, then if we are trying to get all events within the specific stream ID, then that's usually really, really performant. And really, we are getting rarely complaints about our performance in Marten. And we have also like clients like Bloomberg. So it means that some people are keeping there quite a lot of volume. But of course, such approach has its scaling limits, but then event sourcing is a storage pattern. And if we are using, for example, microservices, and we are breaking our microservices in a smaller pieces, then each microservice should have its own database. And the same case is for event sourcing, because event sourcing is not a general architecture pattern. It should be always considered within a specific module. So we can apply techniques like um, have a separate event store between each module. We might even break it down and shard it by tenant. And in Marten, we also allow to do it natively. We can also apply other techniques like archiving strategy that I won't be getting now really deep into that. I can link later on some materials on that, but there are multiple ways how to handle that. So why Postgres for Marten? Because Postgres has, as I mentioned, really great native support for JSON. Even the JSON B, you can put indexes on top of them. And we also are using Postgres as a document database. So it allows us to have read models at the same place. And that can give a really good benefits like strong consistency. So we can use transactions, we can use build unit of work, and so on and so forth. So all of the things that you would expect from the storage library. And of course, that doesn't mean that you should be always using them, like, for example, appending to multiple streams, putting some unique indexes on streams or read models, etc. Because with great power comes great responsibility. But in Martin, we have two rules. One rule is that we take pull requests and we have a lot of contributors. And the second one is that we won't be telling you how to live. So it's quite pragmatic. And this pragmatic approach is what I intend to show you right now. So let's try to go to the code. And yep. So let's start with understanding how we could represent in our code events. Because I mentioned that because we have this representation of our events that I show you before, then how to represent it clearly as I promise in code. So if you are not C# developer, then that's also fine. I won't be using a lot of sophisticated syntax, so I hope that you will be able to following that. So yeah, Karim, this will be a C#, but I hope that this will be relatively understandable. I mean, for example, Java has similar syntax right now and other places. But if something is not clear, then feel free to mm, to mm, to ask the question. So I'm using a syntax which is a record, and it means that this is the immutable data structure. So uh, we have a set of events defined like that. So for example, incident logged, categorized, prioritized, agent assigned to incident, responded. So all of those events that you saw in the in our event storming model, like a simple event storming model. So as you see, all of those events contain only granular information. So for instance, if we are logging incident, then we are putting the customer ID here, but we don't need to repeat this information in all the other events because we can assume that if this event is always the first one on the stream, then we already have that information. So then we have some additional data like contact, description, who logged this incident, and in incident prioritize, we, for example, have the priority, who prioritized that, and if we have, for example, incident resolved, then we have resolution type and so on and so forth. So as you see, those events are really focused on the business. And that's a really powerful thing because by that, we are capturing everything that has happened both technically and business wise. And if we look on this code, of course, if we are enough familiar with the C# syntax or similar, then this can be also some kind of our documentation. So we are also able to have a clear documentation of our business process also in our code. So in the worst case, we can even use it to talk through with our business, of course, by explaining them what we are showing to them. And as I mentioned, the fact that we are using those events doesn't mean that we need to resign from a specific, let's say, state. So in our case, this is incident. And this incident, this decision model should only contain data that we need for our decision making. So if our rules are, for example, that we cannot um, resolve incident unless all of the outstanding questions were responded to customer, or for example we cannot resolve incident that was already resolved, then we need to have those information. So still, I'm using, this is the immutable data structure, um, but yeah, it's like a regular data structure. So in your language, you can use preferred syntax that you want. And Karin, just for your information, for example, EventStore DB recently added the support for Python in their clients. Martin is at currently only for .NET, but we are thinking about exposing it further. So getting back to our process, um, we can also define for each event, we can define apply method. And this is the convention bar Martin, but a lot of other event store has similar convention. So actually, we need to have a method, all of the methods for each event that will be gradually building our state representation. So this one. So once we are reading all the events, then after, for each event, we will call the specific method on our state. So for example, if we are getting incident logged, then we are creating a pending incident with the ID. Then when agent responded, then we are marking this incident that it means it has that it doesn't have any outstanding questions from customer. When customer responded, then we are marking that, hey, agent should answer that. And then if we incident resolved or acknowledged or closed, then we are just updating status. Um, so let's move on. So we have the incident, our model that we will be using in our decision making. So let's try to go and define our business logic. So our business logic, we will start with the intention. So our commands or requests, whatever you prefer to call it. So log incident, categorize, prioritize, agent assign, etc. Usually it's a one-to-one mapping between command and event. However, usually command may contain some less information because some data might be calculated on the server, some might not be available on the front-end side. So it's does in terms of data, it's not always one-to-one mapping. So I just defined again immutable classes that records that are representing the business intention. So think on them like a request that you can get through the API. So let's define a basic business logic. And this business logic is represented, for example, here. When we are getting log incident, then there is no business logic, no if, no validation, because it means that we always can log incident for user. Of course, we might have here some like, if we have, in general, we would have, for example, whether user didn't have maximum amount of incident logs or some other stuff, but this is really a basic thing. And in event sourcing, the business logic can be made really straightforward because it's really a repeatable pattern. So we have our state, so like our decision model, we have our command, and as a result, we are getting either a single event or more than one event. And then we are running some business logic like validation, for example, whether this incident weren't closed already, or we might have some additional stuff like here. So for example, we are checking that if we can resolve incident only if it's not resolved already, and only if it doesn't have any outstanding responses from customer. So see here, we are, after we run this business logic and validation, we are creating new event and returning it from method. And some people are saying that event sourcing is hard to test. And from my perspective, how that can be harder, how this can be treated as hard to test, as there is nothing that is simpler, because you have a pure function that you have, you might have immutable inputs, and it's predictable, so you can, for the specific set of inputs, so state and command, you are getting another response, so in this case event. So that's super easy to test with the uh, unit testing. So now let's try to go to our core, and we have here the document. Uh, so we have here our document session, because all of that is like still a bit enigmatic, because it's just some simple code that probably doesn't look super close to the regular application. So let's add Martin. And as Silvio said, thank you for clarification. So yes, Martin is like, I wouldn't say that it's framework. I would say that it's more like a library, or living in symbiosis uh, with the Postgres. So, but yeah, still, it's like a library that is using Postgres and giving the capabilities, like to use it as EventStore and DocumentDB. And EventStoreDB is a database natively built for event sourcing, and it has gRPC clients, built-in clients for most of the popular languages like C Sharp, Java, Go, Rust, Python, and Node, and JavaScript and TypeScript. So I'm using Martin as an example, but because it's, the closest to me. But if you are using other event stores, then the patterns will be almost the same, but just the API will be a bit different. So yeah. So if we want to add new event, so for example, create new stream, let's say that we are logging incident, then in Martin we can call method start stream, and this method will fail if we uh, if we already have stream with following ID. And if we'd like to put some event to existing stream, then we can model following method, get an update. And Martin has the API that is called iDocument session. So this is our center piece of Martin where you are calling this API. And we have our stream ID, so our record ID version that I will go in more detail soon. And we have some specific handle. And this handle method is like, for example, this one. So we can pass, as the function, we can pass one of those handlers and use it to run uh, the business logic. And here, the flow, and for all event stores, it will be similar. So first thing that we need to do in Martin, we need to call aggregate stream async. And aggregate stream, what it does, it loads all events from the database. Then in the for each loop, it's trying to call our apply methods one by one for each event that was recorded in our event stream. And once it goes through the whole loop, then uh, then we will get the current representation of the state. So we can add additional guard that if this doesn't exist, then maybe we can throw exception or not, depending on our preferences. And then on this state, we are running our business logic. And as a result, we are getting event that we can append to our stream at the end of the stream. And then we can call save changes. And Martin here is quite special because we have the unit of work, and you can technically also append more than one event to the specific uh, stream, but to multiple streams. and then call save chase async, but let's drop it. So here we have the expected version, and let me get back for a moment to the slides. Uh, I found it. So optimistic concurrency is not something that is super special for event sourcing. It's a general uh, way of handling concurrent updates. So even if you are not using event sourcing and don't plan to use event sourcing, then maybe at least you can take this part as the thought that you can take to your project if you are not using it yet, and you should. So optimistic concurrency works like that. That let's say that we have event store, and this is our event stream. We have 3 events so far. And here we are not talking about the scenario for help desk, but for getting money out of the ATM machine. So if we try to cheat the system and at the same time we would try to get money from different ATM machines and we only have $100 there, then if those two people would try to open the screen for withdrawal, then they both would get that our current stream is version number 3. And the first person, when is trying to perform operation, then the ATM machine would send version that, hey, the version that I saw was version number 3. And because of that, the database, in this case, EventStore like Martin or EventStore DB or any other database, because it's supported in all major storage engines, then it can say that if there is a mismatch between those versions, then it won't allow to put any data there. And as we have alignment, because we see that in database we have version number 3, and here we also have the version number 3, then it will allow us to append new event. And in the other case, if the version was free, but the database see that, hey, we already have this version number 4, then it will block us to perform another operation. And by that, we are getting a strong consistency. So I'm showing that to prove you that event sourcing, it can be think about like a regular storage pattern, and event stores can be think about like a regular databases. So you might get, and you usually get almost the same guarantees as in any other database type. So yeah, that was what is more important. And one last thing that I would like to show, a simple trick, is that to show you that Martin is, we are trying to make your life easier, is that actually you can just use this method right to aggregate, pass ID and version, and this is the really simplified API doing the same what you saw before. So let's try to maybe get back to our slides again. Yeah, there they are. And I'm not sure if you remember the web page that was called There I Fix It. There I Fix It was a blog, or actually one of the first pages that was showing weird scenarios. And I was a huge fan of that during my high school and university, which was quite some time ago. But it appears that this page still exists. And this page is still showing a really fabulous way of trying to fix some stuff. So, for example, here or here, the guy is just brilliantly fixes the bike, and maybe just to do the barbecue. So why am I showing you those weird pictures? What does it have to do with events or event sourcing? Maybe nothing. Maybe I just want to wake up you or myself. But actually, it does. There is a relation to event sourcing, because those pictures are showing that many different people have many different interpretation of what can be mean fix, or for example, what how how the how the car should be working, or how bicycle, or how the barbecue should work. And in event sourcing, we also have projections. And projections are a different interpretations of the same fact. So for example, if incident was closed, then support team might be super happy and super relieved about that, but user might not, because maybe they got information that we are not planning to fix it, and this is not a bug, but it's a feature. So, the same event, but totally different perspective. And in the same way, all of our stakeholders, so both us as developers, or help desk agents and business and users, can have a totally different interpretation of all of the events that happened, even though they are, as I mentioned, immutable, representing a specific facts, etc. We cannot change the past, but we can interpret it differently. So going back to more technical things, is that projection, so different interpreting our events in different ways, can be used to build our read models, because loading all events can be fine and performant for the right model needs, because then we are always reading from the single streams. But for example, we also might need to display all the incidents, or somehow in other way. So how to do it? So for example, we can have a regular table that will contain for each stream a separate record, and we can subscribe to the notification from our event store and be notified that new event was appended and registered. So for instance, if we log new incident, then we can add new record to our incidents table. If agent responded to incident, then we might update only relevant information. So for example, the counter of how many nodes or interactions we registered, and when the incident was resolved, then the status is updated, and only status. So it means that also our updates to read model are also precise and granular, because, and in the end, we can have a read model in database that is suitable and fine-tuned to our needs. And if, for example, if we need to have a full text search, then maybe we don't store that in the relational database, but in Elasticsearch, because why not? And one of the killer feature of event sourcing and projection is that a single event can trigger updates to this more than one read model. So for example, we have view for our agent assignment, for incident, and as I mentioned, the incident dashboard for uh, doing the full text search on top of that. And each of those have a different interpretation and can be optimized much differently. And this is extremely important, because most of our systems are built in a way that we have much more reads than writes. So having easy way to optimize our read models is really, really important. And it doesn't mean that we need to have a strong the eventual consistency, because for example, we can wrap our appending of the events and updating read models within the unit of work. So as I show you this save changes, and we can update read models in the same transaction, and Martin allows us to do it. Yet we also may have need to, for example, forward those events and use them to communicate between services, between modules, or we might be publishing that to other type of database, or maybe our read models are so calculation are so exhausting that we should not be doing that in the same transaction as a pending events. Then we might realize that maybe we can use asynchronous projections, and that is how EventStore DB is doing. And in Martin, we are also allowing you to do it. But this is an option, not a must, at least in Martin. So as we have still about 10 minutes, then let's try to show you how you could build the projections in Martin. So it will be a, let's say, a similarly looking projection. I mean, in other event stories will be similar, but I will show you the specifics on how you can do it in Martin. So for instance, when we had the incident, our decision model, then see, we had much less information here, only those information that are relevant and needed for running the business logic, but we kept all of the information that about something that has happened in events, and that's perfectly fine. And that's also showing you how the write model can be different from the read model and why to have it like that. So incident details may, for example, contain all the information that we need for the specific incident. So customer status, all of the nodes, so history of discussion, category, priority, assigned agent, and so on and so forth. And to build such read model in Martin, you can have a following class. So you need to define a class that is derived inheriting from the single stream projection. So it means that for this read model, we will be using always events from the specific stream. Because if we assume that our stream represent the incident, then incident details is also a single interpretation of this view. So here we have a bit more updates. So for example, in each agent assigned, incident prioritized, we are updating relevant information, and same for all the other events. But still, it's a simple code. So simple data transformation. And that's actually, in my opinion, really, really powerful. And if we like to have, for example, the uh, different interpretation. So, for example, instead of having all the history with descriptions and full text search, then maybe we just need some brief information for our list view, because details, let's say that this will be showing the details of our incident, then maybe here we can just leave with the nodes count and maybe basic information. So if we would like to optimize and keep it as a separate read model, sure, we can also have it. So see, we have a same set of events, but different read models fine-tuned for the specific needs. So in this case, the single stream projection, again, using the same set of events as our details. So let me show you different example of the history of the read model. So for example, if we'd like to have a human readable history, for example, for audit needs. So we would like to have the incident ID. So for each incident, we will have, for each update, we will have the description representing what has happened. Quite often, we want to show such stuff. So how to do it? We can use a bit different transformation projection, but similar. So in this case, we can use in Martin event projection, but actually it does almost the same. So we are getting event, and for event, we are creating for each event new record, new history record, transforming data that we had in event into some human readable description. So for each event, it's similar, but with different information and different description. And important thing, what I'm doing here is that I'm also using the wrapper, and I event in Martin is the wrapper for event that contain some additional metadata like I show you. So event ID, the sequence on which this event was appended, the stream ID, uh, timestamp, and event type, etc. So all the data that you saw uh, in the table that I was showing you, and a bit more. So again, we are still using the same set of events, and we are getting yet another interpretation of that. So, in my opinion, that's quite powerful. So, let's get back to slides and let's try to wrap it up. So, the summary, and I hope that with this speed run, I know that it was really fast to try to explain you the details and the practical also way how to start with event sourcing. But I hope that I show you that event sourcing is not that scary. It's different. It might be a bit harder, but for example, if we are learning, if we were building just monoliths and now we are learning how to create microservices or how to use cloud, then there will be always a ramp up phase. We will always need to transition and change a bit our mindset. But event sourcing is not that revolutionary. It's also not that scary as you see on that picture, because I hope that after this webinar, you see that you don't need all that garbage, because event sourcing is a simple pattern. It's a storage pattern. So you are capturing the business intention, running the business logic, and as a result, you are appending new event with the new information about what has happened. And events are really powerful because they are representing the business facts and the business intention. And that's really important because that's getting us closer. And one of the things that I notice is that people are really struggling to how to transition from what they discuss with business to how to see that in code. So in my opinion, event sourcing is a potential solution to that. And of course, it's not that because as the developers, we might say, I don't care about business, I'm just coding. So if you are just coding, then still the worst thing that you'd like to have is to be waken up on the duty call in the middle of the night and don't know even how to start investigating. Or if you have bug and you have hard time to reproduce that and spending time diagnosing it. With event sourcing, as you have the clear history of what has happened, it's also easier to track or even to debug what has happened. And event stores are logically uh, key value databases. And I would like to highlight databases. That's why Kafka is not a database, because it doesn't have basic guarantees like optimistic concurrency, reading your own writes, etc. And all that stuff that you would expect from database. Kafka is great messaging tooling, but it's not a database, at least in my understanding. And event stores are databases where key or ID is the record ID, so like a primary key, and the value is a list of events. And of course, technically, underneath it's an append only log. But hey, relational databases are also technically an append only log. Even 90% of databases have some structure that is called either write ahead log in Postgres or uh, transaction log in SQL Server. So all of them are built like that. That first you are storing that to append only log, and then you are updating the data. And um, so if you are scared about keeping all of the data in single table, you should not be that scared, because databases can be optimized and can take a lot of data, but still you should be also um, you should also understand basic modeling techniques and understand the specific of event sourcing. So if you are applying data governance techniques like database per module or schema per module, or if you are sharding that by tenant, so your customer and so on and so forth, then you should be good with also in event sourcing. Because as again, event sourcing is giving us strong consistency. If we are using Postgres, and obviously we are getting the same guarantees as we have for Postgres. But for example, EventStore DB has guarantees comparable to serializable to regular databases. So the highest guarantee that you might get from database. And in the end, you also have projections, so different interpretation of the same fact. And you can use them to build read models and get optimized read models for your storage needs. And you still can benefit from even updating those read models in the same transaction, but you might also optimize and move further and accept the eventual consistency of the real world and also use it like that. So again, I encourage you to try it to yourself. You can contact me. On the bottom, you have my LinkedIn. You can check my GitHub. There are examples and even self-paced kits how to start with event sourcing in C Sharp, Java, and TypeScript. So I really encourage you to try it or to search some other materials. You can check my blog, and I'm really, really open on helping you. And if I didn't persuade you, then maybe those pictures of martens, those cute animals, will persuade you to try it because they don't bite hard. And thank you a lot. That's all for me.
Well, thank you very much. Thank you very much. Let's stay with that slide. Okay, we have some questions, really good questions. Let's start with Łukasz. I will show them at the bottom. First thing, when would you use Martin and when even store DB?
That's an not comfortable question for me. Uh,
So
but
the
it's a
good
good
one.
question. Yeah. So definitely, so to give the safe answer, then definitely I would use Martin if you already have the experience in Postgres and you are really familiar with that. And if you are using .NET, because if you are not using .NET, then you don't have much option. You should use EventStore DB, or for example, if you're in Java space, then there is also a major event store that I can recommend, Axon. So they are also fine. So that's obvious answers that I could give, but to give more detailed, then I would say that Event Store DB is something that is natively built for event sourcing, and it's a database. So as you look on any database API, then this API is quite raw. So it's Event Store DB is not a library. So what in Martin, for example, we are putting a lot of effort to making that accessible, but we can also do a bit more because we can be a bit more opinionated because we are library and can push a bit more our way of looking at things. And in database terms, so like event store DB, it's a bit harder because you need to be a bit more generic because some people might be doing um, their own infrastructure on top of that. And so I would say that from my perspective, Martin is a bit more accessible, but even StoreDB has some stuff that is a bit more fine-tuned and potentially can have, especially in the future, a bit more possibilities because it's even from the storage perspective, it's natively built for that and can have some optimization. But I would say that if you choose one of those projects, then I think that you should be good. And in Event Store DB, there is also still a lot of good folks that are open to help, and this is quite important. And even Store DB for now, besides Axon, are the only event stores that have really stable financial backing. I mean, they are companies. In Martin, we are still bit non-profit. We are trying to change it. We recently introduced support plans and etc. But that's always something to consider, how vulnerable the tool is for the buzz factor. So I don't think that Martin is vulnerable really to that, because I'm working on Martin like 5 years and 2 months, or even longer, but officially as a co-maintainer. And Jeremy, I think 2 or 3 years longer. But still, we are three people: me, Jeremy, and Babu. And so definitely, buzz factor is is smaller than at EventStore DB. But
Mhm.
we are doing our best to change it. I'm not sure, Łukasz, if that answer. There is Eric here. So Eric, you can put the comments. Both tools. So Eric is one of developer advocates at EventStore, and as I
Mhm.
mentioned, one of those good guys that I told you about.
In the meantime, we have a fun comment from Alexander that Martins are cute as long as long
Oh
as.
yeah,
Okay.
but I don't know that perspective, because I don't have driving license and I don't have
Oh,
a car. Yeah, so but I
that's
heard
the
that.
idea.
I even saw some photos of that.
Mhm. Okay, next question. Next question from Shishir.
Hmm.
How we save event to update write model and read model in the same transaction? Wouldn't the read model
Hmm.
is materialized after event is committed to write model?
Hmm. Yeah. So let me go back to code, and let's go back to document session extensions. So if we have, maybe let's go to this bit more verbose. So first, in the method, we are getting the current state. Then we are running the business logic. And as a result, we are either getting a single event or more than one event. Usually it's a single, but not always. And then we are saying to Martin uh, that let's just append this event to this stream with the specific ID. So in other words, we are just adding new event to the list of events for the specific record. And then, as in the end, we are calling save changes async. And save changes async is like a unit of work. So all the operation that you had scheduled will be run inside of it. So you are opening the transaction here. The first step that you do here is opening the save the transaction, and after that, we can check whether there is a projection that is registered for this specific business type. So how does it go? So let's go to incident short info, and here, by convention, we are saying that for this projection, for this read model, I would like to be handling this set of events. So each event that we have in the apply method. And let's say that we are appending the incident categorized, then internally during save changes, Martin will try to do a following stuff. Give me all projections that are registered that can handle the specific events. So it's like we are caching the list of projection inside our configuration. And once you are appending new event, then we know, because we are registering that, then we know that um, that this projection, all the projection should be handled. And then projection after projection, we are running the apply methods and storing the result, so this outcome of this operation, this read model, as a regular row in the database. The only difference is that in Martin we are using Postgres as document DB, so technically our rows are ID plus JSONB, but if you use any other storage, then the logic will be the same. But the only way to handle that this way is to keep both read models and event storage in the same database. Because without that, you are getting into potentially two-phase commit issues. So trying to orchestrate transaction in multiple databases. So that's probably not something that you should be doing in the same transaction. And for that, I would recommend asynchronous stuff.
Okay. And one more question from Łukasz. Have you heard about Eventus? And if so, what do you think about
Mhm.
it?
Yeah. So I know Eventus and I know Alexei. He's my friend, and I can really recommend trying Eventus. Um, so maybe I would do a small comparison to Wolverine, because I didn't mention Wolverine, but on top of Martin there is also Wolverine framework, and Eventus is because both are to for other listeners and viewers, Eventus and Wolverine are both I would say application frameworks, .NET application frameworks. And Eventus is built by Alexei, and Alexei is also working at EventStore. So definitely, Eventus is really aligned with the EventStore DB vision, and also it's aligned with the best practices like DDD standpoint, or um, Alexei knows his craft, and I know that what he put into Eventus is what he tried on production. So it's based on his experience. So it's battle tested, but uh, the difference that I would show to comparing to, for example, Wolverine, is that Wolverine potentially is a bit how to say it. Um, we it's not so focused on DDD patterns. So some stuff are done differently. Like for example, there are more code like here, so more like a functional, simple functional way, like handle static methods that are just transforming some data. And Eventus is more focused on stuff like aggregates and so on and so forth. Also, Alexei provides option for such handlers, but it's a bit different style. I wouldn't say what is better. It's just I think both tools are nice to use, and I would recommend trying them. Um, but it's good to try both, because then it might be one might be more related to your style and the other to your style. So yeah, but definitely Eventus is one of the best event driven tool that I saw. So
Oh, that was really nice. Okay, we have few comments. Thank you for the explanation. So I hope the guys are happy of your explanation. If you have more questions, put them in the chat, or just reach out directly to Oscar. I have one question from my side, if I may. How would you recommend the client changing the approach? For example, we have long running project, more complex one, and
mhm,
we want to suggest client how to change the approach to use event sourcing. How would you do that? What would you recommend? What should be the
mhm.
steps?
Yep. So mm firstly, I would try to evaluate whether you can really benefit from event sourcing, and
Mm-hmm.
whether um, it brings additional value. So, for instance, I was involved in rejecting a few ideas of using event sourcing. And in my project, we were building a tool for managing the documents workflow. And usually, one of the potential scenarios that I show for event sourcing is that it should represent some specific business process. And that's also the reason why I show and started this narrative of the specific business flow, because then you can benefit from that if you have such flow. However, we were already using the document database, and see, document workflow and document database sounds quite close and sounds like a good matching. So in our case, I think that we still could benefit from using event sourcing, and it could be a good decision. But the document approach for our case was good enough. We didn't have a lot of need for customized projections, or
Mm-hmm.
we could facilitate tracking in a different way. And the most important thing was that I was the only person that was having the previous experience with that. So and we had a project that was spanning 3 countries and 2 continents, so it would be hard for me, keeping in mind the deadlines, etc., to do a proper uh, knowledge sharing with other
Mm-hmm.
people.
Mm-hmm.
So if I would start, and if I say like, okay, this sounds like a potentially good matching to me, then uh, I wouldn't start with the most complex scenario. Even though the event sourcing looks like matching for complex business processes, uh, then if you start with that, especially if it's a new process, and if you are learning at the same time tooling, pattern, and business process, that's a recipe for disaster. So my recommendation would be to start with something that has some notion of the business process, something that looks like a state machine, and something that is not important. So if we fail, then no one will care about that. And something that we can relatively easily deliver to production. So potentially that could be a benefit. Like there was a question like about this difference between Martin and EventStore DB. So for example, if you already have Postgres, then definitely it would be easier to use some EventStore that is using Postgres. There are also others than Martin. And if you could, then you could potentially try that, and then push it to production and see and learn. Because definitely when you are trying new thing, doesn't matter if it's event sourcing or something else, then you will have your mishaps, you will fail to some degree. But if you build this safe environment, relatively safe, or sandbox, of course safe environment is like a famous last words, but still. So I would really encourage to try it like that. Learn your mistakes, do a proper process of the DevOps one, so how to deploy that,
Mm-hmm.
just run it for some time, and then it would be also easier to persuade your friends. Because if they say like, well, but this will take a lot of time, or how will we do it, then you can say like, okay, but see, I already done it. And that there is a really big difference between, from the psychological standpoint, to introduce something new and use something that already exists. So people,
Mm-hmm.
it's easier also to show people your benefits. Or maybe you might just realize that, okay, I don't need this whole event sourcing, it's I don't like it, and just resign from using it. So that's also fine, that's also fine.
Mm-hmm. Okay, thank you. I have two questions from Łukasz. Actually, I think that we can combine them. Is there a case in which you will not use event sourcing? And
Mm,
for the new project, is there a situation that
mhm,
would not use, assuming that we
mhm.
know how to use event sourcing?
Yeah, so some of the heuristics of not using event sourcing I already mentioned. I would say that from my experience, mostly it's about people. It's rarely about technology stack or business, but as developers. So if we see that we are only proponent of using event sourcing, and that it's not giving us enough additional advantage, then maybe this is not the hill that we would like to die on, fighting with our colleagues. So yeah, that's a sad truth, but sometimes we just need to let it go. And I have the article about how to So you can find on my blog where I expanded where not to use event sourcing, but mostly those are people issues. So if we are not experienced enough, if our learning curve will be too long, or our business case doesn't suit, or for example, additional thing, quite often people say that, okay, I have audit needs, then I will use event sourcing. And for me, just the requirement for audit doesn't mean that you should be using event sourcing, because that's also why I show this process and making decision based on events and building grid models, because those are powerful things that you can get out of event sourcing. But if you have only legal need to, I think that my daughter is screaming. Sorry. Uh, uh, yeah, she's quite loud. So if we have just the legal audit need, then we have other simpler things to do it. So that's also not something that I would necessarily consider. Um, but for the new projects, so I'm biased. I'm really biased. But if we have the team that is open and we don't have really tight deadlines, and we see that we can benefit from that, why not? And on the other hand, some people are saying that if we are starting new project, then we should be using boring technology and make boring decision, and that's fine. And I agree with that. However, uh, if we see that it really could add value to our project and that all of us are open to trying that, and especially if we have experience with that, then I don't see much overhead because of using event sourcing, especially if you are not using this clean architecture and all that madness, but just writing simple code. As I show you, I'm a simple man, so I'm trying to write simple code. And so if you are not following, you are trying to cut all other accidental complexity that you might be facing, then why not? Because you know how it is. It's like, we at first we are saying that, okay, let's build simple CRUD, but then we realize usually that it's too late, that we should migrate, or there are always some more important things to do than just change our approach. And especially some patterns like CRUD are really hard to get out of them. They are
Mm-hmm.
really invasive. So if we don't do it since the beginning, and if we are starting with that, then and doing that in a simple way, then it shouldn't be that hard. And in this repository, eventsourcing.net core, there is a self-paced kit that, for example, you can take, do with your friends, and just there are exercises and solutions, so you can do it. Same for Java and Node.js, and play with it and get the sense of it. So of course, this is not a full experience as I'm doing on my workshops, but I know that a lot of people already done it like that and evaluated that with their friends. It's not so hard, I think.
Okay.
And
Thank you very
there
much.
is my blog when there is a lot of articles about that.
I really recommend. Yeah, yeah, yeah. Great knowledge, great knowledge, like knowledge base for everyone. Hmm.
You're making me blush.
No. Okay, I think we can wrap it up. It was lovely discussion. Thank you very much, everyone who was taking part in this discussion, and yeah, good watching for all the ones that will watch the recording. And Oscar, thank you for having you here. Hopefully, we will meet on the next meetup one day. And
Mm.
everyone, have a nice day, evening, wherever you are.
Yeah. Thank you, Veronica, for invitation, and thank you all for joining. I'm always scared on webinar that no one will show up. So thank you for for a good questions and challenging what I said. So yeah, it was a pleasure. Thank you.
Thank you very much. Bye bye.
Bye.